Okay, so we're going to talk about counting principles today. Like I said, combinations, permutations. It's very simple. It's very wordy though, so just to warn you about that, just for the record. We're going to do 8-6 on Monday, and that's going to be our last section of Chapter 8. So, determine the number of ways in which a computer can randomly generate one or more such integers. Now, first thing we're going to talk about, integer. What is an integer?
A number. A whole number.
A whole number. It could be positive or...
It's an integer.
Okay, it can't be negative because it's 1 through 12.
But just the general definition of integer. It's a whole number, no fractions or decimals, positive or negative. Now, in this problem, we are 1 through 12. So, first question I have for you. What are the odd integers between 1 through 12?
1, 3, 5, 7, 9, 11.
Of course, I'm still coughing. I know we're shocked by that. Final answer, get ready. How many total numbers are up there in our list?
6.
Okay, I know, it's exciting today. An integer divisible by 4. So first list them, 1 through 12. What are the integers you could divide by 4 evenly?
4, 8, 12.
So our final answer is...
It's going great.
I know, it's good stuff. Okay, now, other things to show you. Fundamental counting principle. It sounds very fancy. If you have two different events, so the first example is a single event, what we say. You are picking an integer, an odd one between 1 and 12, you're doing a divisible. Separate individual events. If you have more than one event, 2, 3, 4, here's the key. To get your final answers, you just multiply your results together. So if it's something like, what's the possibility of this and this, you just multiply the two final answers together. So fill that in on the blank. You got to fill that in on the blank there. Number of ways the two events occur is, make sure you got that. And get ready. We're going to multiply now. I feel the enthusiasm. Okay, customer can choose one of 4 amplifiers, 6 CD players, and 5 speaker models for your entertainment system. What's the possible system configuration? Well, you have 4 amplifiers to pick from. We have 6 CD players, and we have 5 speakers. So we are going to multiply all of that together for a final answer of 120. It's getting good now, kids. Getting good now. Okay, how many ways can a 6-question true-false exam be answered? Now, 6 questions. Think about your 6 questions.
2 to the power of 6.
Hang on. How many choices do you have for each question? 2, true or false. They each have 2 choices. So we are going to multiply all of that together, or an efficient way to punch it in your calculator would be 2 to the, for a final answer of 64. I know this is very exciting. Any questions on that? Okay, all right. How many 4-digit numbers can be formed under each? Okay, so when you have the different digits, sometimes, they can be 4, 5, whatever. Here we're doing 4. So I'm going to make 4 blanks just to kind of help me out here. Just to kind of think about what can I use in each place. So first thing, leading digit cannot be 0. So that means you can use 1 through 9 here. So how many choices, how many numbers are there 1 through 9? 9. I'm going to put my dramatic dot in for the times, okay? Now, it doesn't give you any other information about the rest of them, so you can use 0 through 9 for each of these. Oh boy. So 0 through 9, of course, 10 choices, another 10 choices, and another 10.
Whoa, 9,000.
And we're going to multiply, you have 9,000. And of course, I probably have more work and more dramatic stuff in the notes than you will on the homework, which is totally fine. Now, same thing, 4 digits. We already talked about the leading digit can't be 0. We did it on the last one. So how many choices do you have for your first digit? 9. Now again, I'm just going to put 1 through 9 for dramatic emphasis here, okay? Now, even. We got to talk about even numbers.
That's just the last digit.
It's the last digit that's impacted to be even. An even number is going to end in either 0. What else could it end in? 2. 4.
0 considered even. 9.
I'll count it as even. Like 10.
Yeah, okay.
What else could it end in?
It's not 0, so.
6. What else? 8. So there's how many choices for your last blank? Now, are there any restrictions about the middle two?
No.
No. So you have the full 0 through 9 on these, or 10 choices. And of course, we just multiply all that together.
45.
So 9 times 10 times 10 times 5. Final answer.
45.
Got it. So still, I think easy, but you have to, of course, be a little careful, like if it ends on an even, something like that, what your choices are restricted to. So any questions on the first page? All right, cruising along. Permutations. Now, you did this last year. We're going to cover it, review it again this year. What's important about a permutation, because we're going to do, obviously, combinations. What's important about a permutation is the order. If the order is a factor in the problem, you use a permutation. If it doesn't matter, then it's going to be a combination. So that's what we're going to talk about here. One important application of this fundamental counting principle is the number of ways you can arrange something. Order. The top's not on your notes, that's just for dramatic emphasis. So anytime they're talking about order, it is a permutation, just for the record. Because you are going to have to distinguish at some point whether it's permutation or combination. But for now, we're going to practice permutations. How many orders, I know drama there, can 5 girls, 3 boys walk through a doorway single file if A, there's no restrictions, B, girls first? Well, let's do A, of course, first. So first question for you, how many total kids are there? 8. So I'm thinking about these 8 kids. 5, 6, 7, 8. Now, part A, there's no restrictions. So if I have 8 kids to pick from, the first kid that walks through, I have 8 kids to pick to go through. Let's say I pick Emily to go through. Now, she's gone through, she can't go through again. How many kids do I have to pick from next? So Ben went through. I can't pick Ben and Emily. And of course, we're going to multiply this together. Or, what's an efficient way to type that in your calculator? 8 factorial. I don't care how you punch it in, you're going to get the same dang thing. I just think it's irritating or obnoxious to type in 8 times 7 times 6 and move it out. All right, punch that in, you get a big number. What do you got?
I don't remember word back.
So factorial's in your math menu under probability. If you forgot where it's at, and I can show you. All right, we're going to do part B. So still 8 kids. But the girls are walking through first. So how many girls do I have to pick from? 5. So one of the girls went through. Now how many girls to pick from? Now how many?
3, 2, 1.
Okay, boys. Now the boys are walking through. How many total boys to pick from? 3. I should have picked a different color than green. And now,
2, 1.
so you're going to multiply that, or of course an efficient way in your calculator. The blue is 5 factorial
Times 3 factorial.
However you want to punch it in, you do you. I don't care. What's your final answer?
20 times 2, 3 factorial.
Final answer is 720. Thank you, Mason. Got it. All right, any questions on those? Okay, you're up. Try the next one. Okay, A of course is easier. First question for you, 3 couples. How many total kids is that?
6.
6. So there's no restrictions. So how many kids of the 6 do you have to pick from for the first seat?
It's just 6 factorial.
Yeah. So 6 factorial, or type that in, whatever you want to do. First answer. Now I do think B is a little trickier. Each couple sits together. Now remember, there's 3 couples. So let's get into this. So I haven't sat anybody down yet. I haven't made the assigned seats yet. How many kids do I have to pick from for the first seat? 6. Now, let's say I pick Lola. She's in the front seat. She has to sit by her significant other. So how many kids do I have to pick to sit next to Lola?
I see.
That's weird.
Now, how many kids do I have to pick from for the next couple are left?
4.
So let's say I pick, I don't know, Sophie. She has to sit by her significant other. How many kids to pick from?
1.
Got it. How many left to pick from?
1.
Multiply it. Final answer. 48.
Yeah, I just did 3 times the factorial.
So that's a little trickier, I think, because you have to sit by your significant other. All right, calculator time, we're gonna look at this here. Now, permutations given n at a time. So first up, here's the formula. I always honestly question, is it worth making you even write down the formula? Because we're gonna do this all in your calculator. So just a little quick review, math menu that's under probability. Now, we've already used factorial. We're going to be using, we've used number 3 in the past. We're going to use it again today. We're also going to start using number 2. One of the questions is, how do you know whether you're using this formula or it's like these previous problems and you're just multiplying this stuff out? Here's how. Here's the difference. Read this one. How many different batting orders, that tells me permutation order, can a baseball coach create from a team of 15 players when there's 9 to fill? So here's the thing. You're not using all 15 players. So it's not just going to be 15, 14, 13, 12, so on and so forth. I'm going to use a permutation. There's 15 total to pick from, but we're only selecting how many? 9. So when you're only working on a certain amount, you can just use this. Okay, punch that in your calculator. You get a very large answer. Let's see if we can read it. 1. There we go. I hear it. I'm very happy we don't have to write out all those different possible batting orders. Super happy about it. Okay, any questions on that one? All right, let's read the next one. 8 sprinters have qualified for the finals in the 100-meter dash. How many different orders? That's just for drama, because eventually you're going to have to read and decide permutation or combination. Order, of course. Top 3 finishes, assume there's no ties. So order, of course, tells me permutation. How many kids do we have to pick from? How many are running this thing? And we are only looking for the top 3. Okay, punch that in. 336. Any questions about permutations? So again, when I switch to the p-value here, the last 2, because you're not using like all 8 sprinters or all 15 on the batting order, you're selecting an amount from it. That is the difference. All right, this is just kind of a weird random one here. Yeah. So find the possible permutations of those orders. Okay. So just to make your life easy, count it quick for me. How many total letters? 8. So I'm going to do 8 factorial. Okay. How many B's are there? How many T's are there?
This is minus.
Just say that again, as what?
Never mind. Just keep going.
Okay. How many T's are there? That's a sloppy 5. So just, and we'll punch that in and blah, blah, blah in a second here in just a minute. But what I'm working off of, just to flip it back here, is this. I'm just going old school formula. The total amount of letters, that's our n, the total, the 8. And then, of course, it's the different letters you're working on. So I just punch that into my calculator. I'm not going to bore you and make you do it. You get 56. So that's just kind of this one random case problem that's not as straightforward as the others. All right, that's everything for permutation. Let's talk combination. So clearly it's in your math menu under probability, same old spiel, blah, blah, blah. Obviously the difference is the order does not matter. And again, I don't know why, but here's the formula. We're gonna, of course, be using your calculator. Notice the difference. Permutations is just the n minus r factorial on the bottom. Combinations has the additional r factorial. And you're gonna love example 9. Feel the sarcasm. Okay, ready for 9? And again, I always question every year, is it worth me making you write these formulas down? Because it's in your calculator. We're going to use the function on your calculator, but I feel like we should know kind of what the formula is for it. Okay, yeah. All possible selections of 3 letters that can be formed. The order's not important. So combination. Now, we have to write them all out, actually. But before I do that, I kind of like to know what's the end game. How many am I going to have here? So off on the side, how many total letters are there?
6.
And we are selecting how many?
3.
So I punched that in. I did it earlier, obviously. And I'm trying to sneak a 20 in there. I'm running out of room. So we need all 20 arrangements, combinations of those letters. So, meaning you could do A, B, and C. This is why this one has more room. I could do A, B, and D. That's a sloppy A. We could do A, B, and E. We could do A, B, and F. Are we having fun yet? You could have A, C, and D. You could have A, C, and E. You could have A, C, and F.
Could you?
We could.
Oh, okay.
How about A, D, and E? And notice I'm not getting crazy and being like, oh, D, A, E, D, E, A, like all of those. This combination, the order doesn't matter. I don't have to put every ordering down. Just what 3 letters can you pair up? All right, what else do we not have together? A, D, and F. I don't have those 3 together. I don't have A, E, and F together.
Well,
Let's see,
guess
I need
B.
B, C, and D. I don't have those. I don't have B, C, and E. I don't have B, C, and F.
Wow, this is
B, D, and E, I don't have together. I don't have B, D, and F. This is an E, sorry. I don't have B, E, and F. Okay, you guys are very positive today, enjoy it. We need 4 more. What are the final 4?
I don't know.
Who cares?
What kind of attitude is this?
It's a giving up attitude.
We already have the answer.
We don't have C, D, and
I don't know.
E, I heard it, and F. We don't have C. I'm trying to write a C. That's supposed to be a C. A C, E, and F. And we don't have a D, E, and F.
Why do we need this?
Now, for fun, what if it was a permutation where it said the order did matter? What is, punch this in your calculator.
I don't want.
Punch it in. Do it. Punch it in.
You don't. Stop.
No.
Oh, wow.
We're not gonna do that, are we?
What's your total there?
120.
So how about, thank you, Mrs. Pryor, for not making it a permutation and we had to do all orderings and there's 120 of them.
I didn't
do this one. I wasn't gonna do
You're
that one.
you're
I'm
welcome.
the kinda sane person.
You're welcome, kids. You're welcome. Welcome. Okay. Welcome. All right, you can answer any 18 questions from a total of 20 questions on an exam. That just seems dumb. You should have to answer them all. But anywho, how many different ways can you select the questions? All right, so are you using a permutation or combination? Does the order matter?
No.
No, can I answer a test any way I want, the order? So combination. How many total questions are there? 20, and you only, for some weird, unreal reason, have to answer 18. I don't like that at all.
Bonus questions.
Okay, punch it in. 190. Got it. All right, you guys try this guy.
Party affiliation.
So first question for you, permutation or combination? Combination, because who cares the order? How many total are there to select from? And you are picking, now you were gonna get probably a weird answer on your calculator. Does it have an E in it?
Yep.
So remember, that's scientific notation. So I would put, let's round it, like 4.42 times 10 to the 16th.
That's a big number.
That is. Be grateful we don't have to write them all out.
Plus a zero.
Again,
I wouldn't mind.
you're welcome. All right, we are on the home stretch, everybody.
Yeah.
I feel the enthusiasm from Ben. Okay, okay, let's talk cards here. How good are we with cards? So okay, I'm gonna click ahead.
No.
Now,
That's not right.
I don't expect everybody to know what's in a deck of cards. Not everybody plays cards. I am going to post a picture of this on Google Classroom. You will be provided this picture if you need it on a quiz or test, just for the record. So first thing, let's get into it. How many total cards are there? 52 total. How many suits are there? 4. So when we're talking about the suits, what are the suits? Diamonds, hearts, spades, clubs. Now, how many of each type of card are there? Ace through king. 13. There's 13. Okay, and again, I don't expect everybody great with cards. I will post a picture of this. You will be provided it. Let's get back to it here. You're dealt 5 cards from an ordinary deck of 52 playing cards. How many ways can you get a full house? I didn't know if you knew what a full house was, so I put that on here.
Yeah. Thank you.
3 of a kind, 2 of another. And I gave you a couple examples there. So like 3 8s, 2 5s, 3 kings, 2 10s, etc. So first question, permutation or combination? Does the order you have the cards in your hand matter? No. I mean, I like them together, right? Like organized, but does it really matter? No. So I'm going to use combinations. Now, we're doing, remember, 3 of a kind. So we're going to first talk about that, and then we're going to do 2 of a kind. And of course we know, bless you, we're going to multiply our answers together. And we know we're using combinations. Now, 3 of a kind. So just for example, I'm going to think about these 3 8s. So I'm going to my deck of cards. I'm thinking about, I've got these 3 8s in my hand. So the first thing, out of the 13 different cards, I selected 8 for this example. Doesn't have to be 8, but for this example. So I'm going to put out of the 13, I picked 1. I picked the 8. Now, we got to talk about the suits. Because maybe I have an 8 of spades, 8 of diamonds, 8 of clubs. So out of the 4 suits, I have how many? 3. So that's your 3 of the kind. Now, the 2 of a kind. Let's go back to the picture. So I picked 8 for whatever reason. Now, we have 2 5s. Is that what I used in our example 5? Yeah, 2 5s. So here's the thing. It's going to be similar to this, but I'm going to change this first number. Because I took 8. I have 3 8s. Can I have 2 more 8s? No, there's not 5 8s in the deck. So I don't have all 13 to pick from. I only now have the 12. And of course, let's say I have a 5 of diamonds and a 5 of spades. Out of the 4 suits, I have how many? 2. And of course, I'm not going to bore you with punching that in the calculator. You can punch that all in later, whatever. I'm just going to give you the final answer. It's the setup that's the key. So any questions on the setup of the cards? And like I said, I'll give you a picture of a deck of cards. I don't expect everybody to be a master at it.
Can we play poker to study this?
God. Good question, Alex.
Be educational.
What is, all right. Law office interviews paralegals for 10 openings. There's 13 paralegals with 2 years experience, 20 with 1 year of experience. How many combinations, that's pretty obvious, we're using combinations, of 7 paralegals with 2 years and 3 paralegals with 1 year. Okay, so let's start with the 7 paralegals with 2 years. Combination. So how many total, read it closely, paralegals are there to pick from that have 2 years experience? 13, and we want to hire 7. Okay, 3 paralegals with 1 year. How many total paralegals are there to pick from that have 1 year experience? 20, and we are selecting, and of course we're going to multiply those together. And I punched it in earlier, obviously you get a large answer, 1,956,240. Any questions on that? Too easy. Okay, you guys are up. Try this last one. I feel like this is more reading than actual math today. Punch it in, the whole 9 yards. I'm going to make sure you can type it in. And then we can talk about our love of math. This always Ben's very positive.
Ben is positive in all of our classes.
Ben, I will miss you next year.
What are you?
We've had 2 years of math together, yeah. A lot of you have had 2 years of math together.
That's not as big as a number as before.
It's not awful. Anybody brave enough to say their answer?
462.
So 462,000 should be your final answer. Good job, Nick. Just to set it up really quick if you didn't get it. So it's 7-1, 12-3, and 25-2.
I did it completely wrong.
Is there anything I can answer or help you with,
You didn't
Ben?
write down anything.
Yeah. No, I didn't write down a thing.
Oh my Lanta. Okay. So obviously on your homework there is not a lot of work to show. I just need obviously your setup and final answers today. It'll probably take you longer to read it than anything. So